Hey all. Main. Maintaining E2E test automation as we transition from view to compose. Just a reminder again, this presentation, this talk will contain code. So if you're at the back, you may want to move forward to get a better view. But let's start. Hey all, and in the live stream, I guess. I'm Shinmiy, and
I'm kenken.
right, and we're Android engineers at Mercari by day, and we're also DroidKaigi committee staff. So this explains the whole Japanese style theme, sort of happy, and all the t-shirts and all that. So, all right, start. So just a quick agenda, what we're going to be talking about today. So first, the Mercari app scenario, our sort of scenario that we'll be looking into for today, the Mercari app, and sort of what we're doing with it, what's going on with it, and also maintaining and migrating E2E Test Automation, how we go about sort of maintaining E2E tests that we might have, and migrating stuff to Jetpack Compose, and some general tips that may or may not help you in writing E2E tests. So we mentioned that we work with. Why are you down here? Come up. So we mentioned that we work as Android engineers at Mercari, which sort of covers the payment features for Mercari. And what Mercari is it's one of Japan's sort of largest marketplace apps, with 22.6 million customers using the service each month and buying and selling over 254 billion Japanese yen, which is roughly about 1.7 billion US dollars worth of goods. And it also has payment features to accompany with it. So think barcode payments, credit cards, and lending, and so on and so forth. So just to give you a sense of scale, in terms of employees, over 2,000 employees are working on one single sort of large service. And in terms of Android engineers, about, I think the number is correct, 40 engineers for the Android app alone, I guess. Some people in the front may correct me, but and so that's working on basically one single code base. So we're looking at sort of over 100 pull requests each week, and that amounts to like 4 to 5 figure lines added and deleted each week. So things can get chaotic pretty quickly, really fast actually. And so in order to keep up with this, the app runs on a 1-week release cycle or 1-week release train, which means that, for example, branch cuts and sort of deadlines to merge stuff into the main branch occurs on, say, Wednesday, and then we start release judgment tests from there and then ship on the following Tuesday. And that cycle sort of repeats itself over and over. So this was originally a 2-week process, and so not as systematic as the one we have now. So handling, for example, hot fixes were substantially harder. So the transition to this has given some sort of sense of rhythm and pace. So in reducing this 2-week cycle to a 1-week cycle we have now, everything was halved. And so the process of release cycle judgment tests were, so basically everything was halved. And the process of release judgment tests were halved as well. So we needed to really streamline the process. And in doing so, we started adding automated E2E tests to sort of systematize stuff. So briefly about E2E test or end-to-end testing. It's a test, E2E tests are tests that simulate a real-world scenario, and sort of they check the entire app as a system, as opposed to like one certain feature or one certain component of the system to ensure it's working. So in releasing the app, these tests are very essential in that they look at the entire code. But They do have their pros and cons. The good thing is that it's comprehensive. It looks at the entire system to see if it's working. But the cons are that they don't really test the inner workings, and they're very time-consuming. So it's best to combine other types of tests, which we do have, like unit tests and sort of individual QA for features that are done before the merge to the master branch. So there's some tests there as well. So in testing the app, a typical test, at least for our app, looks like this. So we would spawn an account, whether it's pre-existing or created by an API, and we log into it, .login user login use case, and we would navigate to a screen that we're trying to check, and then lastly we check its behavior, assert, for example, in this case, value would be displayed or not. So we have a ton of these tests in sort of like a larger system, which looks something like this. So the CI would look something like this. The entire automated workflow starts either by a user initiating the GitHub Actions script by a pull request with a label on it, or from nightly builds that trigger the test as well. And then the script triggers tests on Firebase Test Lab, and then once the tests are done on multiple devices, it triggers, it calls the API to a service called TestRail, which sort of looks at the test. Just a brief overview of the individual components. TestRail is a tool or a service to track all the tests that we have, and it's like a source of truth in that all test cases are maintained there, and then so in return all the automated test cases that we have map one-to-one to a TestRail test case. At least most of it does, and it also has a good sort of suite of APIs that they have, so we can call stuff from the outside and then connect sort of to the service via sort of APIs and automated CIs. So, for example, we would call an API called add result for test case, and then once the test cases are done, and then calling this API would update the result for the test case on TestRail. So it's a really good tool that we use. And then calling that is we run stuff on Firebase Test Lab. It's a tool that is used to run tests remotely on real devices that the Firebase team has, and then we call it from a tool library called Flank, which is used to sort of run all the tests in parallel. So, and that's sort of our situation in terms of testing. And then on top of that, we have a thing called Ground Up App, which is a 3-year-long project to rewrite the app that was released last year. So it's rewritten from the ground up, hence the name. We call it GeoApp for short. And then and there was a lot of stuff involved, including a new design system or a system of UI components that we would use to sort of piece together certain screens. So individual components would added to screens. So for Android, and also that means for Android, this app means Android View, converting from Android View to Jetpack Compose. And then so imagine having smaller composable components for each design component, and then we use them to sort of build the UI on the screens. So for most of the features at least on the marketplace, the rewrite was undergone in sort of one giant update. And then for payment features, we're gradually migrating features to the new design system in Compose. So we have a mixture of the two right now. And then there. So our scenario for today is that there's an app that has both Views and Jetpack Compose. And there's ongoing feature development with both Jetpack Compose and the sort of traditional view system. This is necessary because existing features are still in use, and so we do have to maintain them. And then, but for newer features, we try to create with Jetpack Compose wherever we can. And then for existing features, we do like a gradual feature by feature migration to Jetpack Compose. This stuff actually takes time because payment systems tend to be sort of complex. Legal stuff are involved. New design, rethinking features. People are gone. Specs are old, and 5-year-old code is hard to understand at times. So, but so there's basically there's an app that has views in Jetpack Compose. So, with all of this going on, how would we go about maintaining sort of and migrating our E2E tests that we have? Let's look at what those tests would look like and sort of the actual implementation and migrating them. So let me pass it on to kenken.
Okay, so let's talk about the implementation. First, look into the instrumented tests, which are the foundation of E2E tests. First is a brief review of how UI tests are implemented for the traditional Android view. In the conventional Android view system, many projects use Espresso for the traditional Android view UI testing. We use it to find views by their ID or some semantic properties like text or content description and their hierarchy, and interact with them and finally assert them. There is a useful cheat sheet for Espresso is provided by Android developers. So when you have time, please take a look at it. Okay, so let's see a sample screen and how we implement the UI tests. This is the conventional Android view-based UI screen with an XML layout. On the screen, there is a button and a text view for displaying the number of times the button was pressed. An extra text view is placed at the top left of the screen. It is used later to check to see if the screen is created by Android views. Okay, if we write a UI test to confirm that the text view updates after the button press, it will start like this. First, we use the activity scenario rule to set Android view activity as our UI entry point. And this counter test is actual test code. First, we check the initial display of text view by finding the component by their ID counter label. We get to the value count 0 at first. Next, we press the count up button. Here, we get the reference to the button by the count up button ID and trigger a quick event. Interactions with the view are done by passing an argument to the perform method. Finally, to make sure the button press was correctly counted, we check the value of the text view once again. This is how we test with the conventional Android views. Next, let's look at how we would implement UI tests for screens targeting compose. We use the compose testing library for UI tests targeting compose. Here, there is one important point that we need to first go over. In compose, composables do not have any IDs, unlike traditional Android views. There are test tags that we can use as an alternative, but the official document states that we should match nodes using semantics, and test tags should be used as a last resort. Besides, in testing for compose, we use something called the semantics tree to interact with the UI. Semantics tree represents semantic meaning and convey the information to accessibility services or testing tools. Details about the tree are also in Android developers' official document, so we recommend taking a look at it when you have time. There is a cheat sheet for compose test as well. So it's better to refer this document when you write UI test for compose. So let's now look at testing for compose using a compose version of our sample app. We have a count up button and the text to show how many times the button was pressed. And there's also a text on the top left side for ensure this is created by compose. The entire code look like this. The compose test rule is there to set compose activity as our entry point to test the screen. It's very similar to activity scenario rule, and we use it to interact with the UI too. We first check the initial state of the text again, just like we did before. With the example test for Android views, we checked if the count 0 is set to a text view by looking for the ID. But in this case, we checked to see if only one node exists on the screen. That is, count 0 exists on the screen. Next, we press the button this time. Instead of looking for an ID, we look for nodes with the text count up and trigger a click event by perform click. Here, some of you might wonder why we can get the button with the only the count up text, since the text set not to the button but not applied to the text itself. This time I don't explain in detail today, but if you look into the button composable implementation, you can see that the button handles the count up text as its semantics property. The semantics properties of button and text are merged this time. Finally, we check to see if the text is count up to 1. So we've talked about how tests look in screens using the conventional views and Jetpack Compose. These examples were very simple and easy to understand, but as we develop more features, the test code can get bloated very quickly. then readability and maintainability can decrease if you continue to test without thinking too much. So it's a good practice to use a design pattern like the page object model. The page object model is a design pattern to isolate UI from test code. It has page in its name, but it can about the entire screen, or just a small fragments, or just one component. The actual implementation of the UI interactions are hidden on the page object side, so that the test class has only have to call the page object methods. As a result, the test code does not need to be aware of UI implementation details, thus increasing readability. This componentization also improves the code reusability and maintainability. You can also chain method calls, which makes it easier to implement. It looks something like this. By grouping the UI interactions into a page object, you can avoid writing similar code when it is called multiple times from different test codes. The page object would look something like this. This is a page object for Android view activity, as we saw earlier. Individual components are hidden inside this class. Then only abstract interactions performed on the UI and assertions are exposed. In this example, the click counter button and assert count label are exposed. Also, the page object itself is used as a return value for method chaining. This is a composed version, or much of it looks the same for composed screen. In the case of test for compose, the compose test rule is required for interaction with the UI, so it should be passed externally. And a new argument, substring equals true. We pass to onNode with text method is to search for partial matching. Which means searching a node with counter 0, counter 1, counter 2, and so on and so forth. This is the before and after for using page object for our test. This is the Android view version. We can clearly understand the intentions of each line by its name. This is the same for compose. The right code can easily understand. We can see that we can write both tests in mostly the same way by comparing two test codes. We'll use these test codes as a starting point to look at how we would migrate E2E tests. Okay, so let's now discuss the steps to maintain E2E tests as we migrate from Android view to compose. Here, we assume that we are migrating from Android view to compose without changing any features. It means that we create a new compose-based screen, which have the same features as the existing Android view-based screen, and then gradually replace them. By replacing, we also assume that there are feature flags in place to switch these UIs. Therefore, we would temporarily have two types of UI implementations in production code. In this explanation today, we use the screens we've already looked at. It's a bit long, but we will do this in a 7-step process. First 3 steps are for production code. First, we will start by creating the compose screen that we will migrate to. I skipped this part because we already looked at both implementation in our sample code. Next, implementing feature flags mechanism. We add a flag to control the navigations to those screens so we can switch between them. There are the changing we would make to the production code. After that, we will make changes to the test code. First, we will create a page object interface with the method needed to interact with the screen. We will then implement this interface for Android views and Jetpack Compose. Next, we prepare a fake feature flag mechanism to switch the feature flag settings in test environment, so that it can be replaced with the one for production. Finally, we will prepare a mechanism to switch between the different screens so that the page objects can be replaced accordingly. Okay, so let's look at the specific code. First, we make the screen for compose. This is the sample we've already seen. And next, we add a feature flag mechanism to the production code in order to control which screen would be displayed. For simplicity, we create feature flag provider interface and implement should use compose screen to return set value true this time. In an actual development, you would usually receive this value from some external resources. Then we configure to bind a feature flag provider interface and its implementation. In this case, we use dagger hilt like this. This flag is then used to replace the launching screen. In this example, we simply inject the feature flag provider directly into the main activity by injecting this object. This will determine whether Android view activity or compose activity is launched when the button is pressed. Yeah, next is the test code. Let's see the page object interface at first. This transition target page interface is for defining common method to expose. The above two methods are the same as what we've used in the previous page object. In addition, added a method to assert if the current screen is the correct one. And here's the implementation. Just like we explained in the previous section, we inherit the transition target page and as the implementation for assert screen name. This is the same with the page object for compose. Then we add a method for switching between these page objects in companion object. Here we create a static method in the transition target page, and it simply switches page object according to the flag. Then we write a configuration for injecting this fake feature flag provider. In our case, we will use DroidKaigi again. By using the test installing annotation, the DI module specified in the replaces parameter is replaced so that the feature fake DI module is used only in the test environment. Then we configure the setting to inject the fake during E2E tests. The E2E testing section of the DroidKaigi document has more detail about it, so please refer it. Now finally, we implement the main page object for main activity with one navigation button and write our test code. Transition target page is returned as a return value of the click navigation button. In order to transition the Android view page or compose page when the button is pressed. Then, by passing the value of the feature flag as the argument of the click navigation button method on the test code side, we can make the test depend on the value passed by the fake feature flag provider. Yeah, to sum it up, we used a page object to create a common interface between the two implementations so that the test code is the same regardless of the implementation. And added a mechanism to switch between the two. In this case, we added a feature flag. Yeah, that's it for me. So back to shinmiy again.
All right. So we looked at the implementation details and sort of how to actually implement the tests, but there's always teams involved in this as well. So the way you would go about maintaining this sort of structure would vary depending on sort of the company or the team or the app you're working on. But in doing it for us, we sort of generally recommend. We found it best to work or split roles between the QA team and sort of the engineering team. So the QA team would create and maintain tests in TestRail and then sort of hand over as tickets to the engineering team. So for example, the QA team would create new test cases, update existing test cases whenever we sort of migrate stuff, and then initially flag the TestRail case as a manual test, and then test it manually in the following sort of release checks, and then create a task ticket for it for the engineers to work on, and then sort of work together to prioritize which test cases to automate, and then implement the E2E test automation from there. And then once we're done, we update the TestRail test case to automate it so that we don't have to look at it manually from the releases following. So by doing so, you can sort of split tasks among the Android developers because you have individual sort of tickets for individual test cases, which allows you to sort of divide and conquer each automated test. So this is actually good because it's a chance to work sort of as a team because everyone on the team is working on the similar tasks individually. So it's a great opportunity to sort of share tips that you found throughout implementing tests, and it allows you to sort of for example, pair pro stuff or mob pro stuff, or sort of talk about sort of testing or the code you're writing on while you're waiting for the builds. So it's a great way to get creative and use it for team building. And also, we find it best to sort of keep a document that everyone can write to whenever you find some like tips or tricks or some gotchas that you found, so that you keep like a whole list of things that people should sort of know about when testing. So, which brings us to the general tips section, which is straight out of our sort of list of hacks or gotchas or whatever we noticed. So the list is getting bigger, but we found some things that we could share. And so here are some tips from the list that may or not help you when writing your own tests. This is sort of like the basic part that you might already know about, but at least I feel that it's the first sort of wall when you're writing tests for Compose and E2E tests. It's about waiting for tests, and so sometimes in sort of implementing E2E tests, you have to wait for tests like animations or network calls or transitions, and the first sort of thought process the first thing you would try to do is sort of thread sleep stuff, but having like a constant millisecond timeout or a sleep makes the test really flaky. You don't actually know when the sort of, for example, the network call is going to complete. So it's generally not recommended to do that. We have wait until to wait for something to be completed. So everything in the sort of like inside the brackets, whenever that is complete, the test sort of moves on to the next step. So there's a couple of ways to do this. Starting Compose 1.4, we have wait until, but we have other sort of more granular sort of methods on the API, like wait until node count something, or wait until at least one exists, or wait until exactly one exists, so on and so forth. So this one I really wanted to share. There's two methods in the Compose test API that are very similar, but they do very different things. So onNode with tag and onNode with text they have the similar name. It comes up next to each other in the autocomplete, and they have very similar arguments. They both take strings, so it's very easy to get them mixed up. So I really recommend reading what you write, especially when it's auto-completed, because you'll find yourself writing something like this with onNode with text and then passing a test tag, and then the test won't complete and you're left with like hours of debugging the actual code, and then turning out to be like one simple method call error. So trust me, it'll save you some time. Multiple matchers. Yes, this is also something basic, but it's good to know that it's there. You can look for nodes using multiple matchers. So you can chain sort of semantics matcher, like has test tag for a bottom button, and then plus having text. For example, in this example, details. So it's pretty simple, but and if you look inside, it's just a method of semantics matcher that takes another semantics matcher for the argument, and it's an infix, so you can sort of chain them. And inside, it sort of does what it does to create another semantics matcher, which it returns. So very basic, but it's good to know that's there. And this one, working with subcompose layouts. This can get really tricky when you're subcompose layouts, or what they are is they're layouts or composables that you use when you're trying to limit, for example, place one node in relation to another or limit the number of nodes that are present on the screen. So when you want to use one node in relation to another node, and then you can really customize stuff and get into this rabbit hole. But it's easy to sort of, this is fun to use, but it creates a giant gotcha when you're writing tests. It creates the same instance of, it creates multiple instances of the same node. So when you're searching like on node with tag, the test can fail right there. So if you look inside, this is a condensed version of the sample implementation. Inside you can see that it's calling subcompose multiple times, and then measuring stuff multiple times. So it keeps track of the nodes multiple times. And so if you do something like this, you can see that only one of the tests pass, a search checks fast, because only one of them is actually displayed on the screen. So it's easy to overlook when you're only writing tests and you don't really know about the implementation, but you have to really know that it's there. And we really couldn't find a simple solution to this, but the best we can do is either fetch all the nodes and work from there, or add a test tag inside the subcompose sort of implementation, so that you have a test tag on the node that you're actually displaying. So it's not really good because you're sort of changing the production code for the test, but that works as well. And lastly, I know we're going over time a bit, but lastly, we started using GitHub Copilot and for our implementation. And the reason why I'm mentioning it here is because it acts as like a smart code completion, but it's especially good for repetitive code like E2E tests. So it gives you like a good base to start when you have multiple functions or multiple methods that are similar to each other, and then you're adding one extra one. It sort of pre-fills the sort of tests that you're trying to write. So it's actually good. It gives you a good place to start with, and you don't really have to write or copy and paste each code and then worry about imports and all that stuff. And also, it's good. This is not exactly E2E tests, but it's also good for like pre-filling data classes, and sort of when you have, like for example, in this example, you have feature flags. You have a certain key. If you write a comment on it, it sort of names the enum sort of accordingly, and you don't really have to sort of think up of a different key, a suitable key. So it's good. It's really helpful there as well. So, all right. So coming back in conclusion, automated E2E tests sort of can save resources and help streamlining with release processes. And I think it's safe to say that we're all sort of in the process of migrating sort of Android from Views to Compose in a lot of projects. But we can sort of migrate by using, for example, introducing feature flags mechanisms sort of to switch between two projects, and then use, for example, a page object model for test implementations, and then create a fake, and then switch between the tests, but keep the E2E test write the E2E test in a very similar fashion, so you can easily switch between the two. So, and also when you're working on a team, it's great to work with the QA team to sort of divide and conquer individual tests. And there's many tips to share within the team. It's a good opportunity to sort of have fun within the team, use it as a team building process, and migrate as keep the migration going and have fun with it. All right, so that's it for us. Thank you. Enjoy the rest of DroidKaigi 2023. Thank you very much.
Thank you very much.